welcome to this class. Today we will be looking at short and long division method. Actually, this particular topic is a concept that should take us a minimum of 2 weeks. So even though I am making a video, uh, even though I'm combining both concepts in this class, it still does not mean that we will finish it in 1 week. It will take us 2 weeks because it involves a whole lot of steps to master it. Okay? But we will first of all be starting with short division method. Now, short division method is simply a way of dividing numbers bit by bit or digit by digit. We keep on reducing the numbers till we get to a point whereby the dividing number will become 1. Alright? So having said that, let's look at some examples and see that short division method is actually very simple and friendly. Okay? So let's solve some examples. Examples. Solve the following. Number 1. Let me have 9 divided by 3 by short division. Alright? So solution. 9 divided by 3. Short division is always arranged in this form, in a fraction form. Okay? Now I'm using a very small number. Before, we normally use the method of sharing to do this division, where we will quickly make 3 persons sharing 9 apples. Now each person is having how many? 3. Okay? Meaning that 9 divided by 3 is 3. Right? Sure. But I divided this using short division, using sharing method. Now, remember what I told you. Division and multiplication are inverse in nature. You can use multiplication to divide a number. Okay? Now, ask yourself, what number will you multiply by 3 to give you 9? 3 times 3, 9. Therefore, 9 divided by 3 is 3. Okay? Now, this is not short division. I'm only bringing to our consciousness things we already know, things that will help us with division. Okay? I hope you are seeing the reason why I said you must master your multiplication table. Okay? At least from 2 to 9. 10, 11, 12 can sort themselves. Okay? 2 to 9. Very important. Alright? So, when you are dividing a number, you can actually ask yourself, what times what will give you the number you are dividing? What are you going to use the divider to multiply to give you the divisor? Alright? Okay, since I remember divider and divisor, 9 over 3. The numbers up are called the divisor. The numbers down are called the divider. Alright? Divisor and divider. Then the answer you got, like you have that 9 divided by 3 is 3. The answer you got is called a quotient. Alright? It's called a quotient. Is that okay? Alright. So having said this, let's now move into short division proper. Okay. Sorry. inverse, number 2, let's say here I have 36 divided by 3. Again, solution. So here I have 36 is my divisor, 3 is my divider. Now look at what we call short division. Now, short division is simply using these 3 to divide 36 digit by digit. What are the digits that made up 36? 3 and 6. Now, instead of using 3 to divide 36 at once, we divide 36 digit by digit. So let's go. 3 divide 3, 1. 3 divide 3, 1. 3 divide 6, 2. What number are you seeing here? Meaning that 36 divided by 3 is what? 12. This is what we call short division. It's simply a systematic way of dividing numbers digit by digit. Now, there are situations whereby the first digit cannot be divided by the number. Now, what happens? We combine the first 2 digits and divide. Now, having said that, let's look at number 3. Let's say here I have let me have here 45 divided by 5. 45 divided by 5. Okay, now you see that in short division, 5 cannot just divide 4 because 4 is less than 5. Solution. 45 divided by 5. 5 divide 5, 1. Can 5 divide 4 alone? No, it can't. Okay? No, it can't. Now, since 5 cannot divide 4, we have to now merge the 2 numbers together and divide. So we go. 5 divide 45. 9. Because 5 times 9 is 45. Meaning that our answer here is 9. Number 4. Okay? Now let's go a bit up. Let's have 24 divided by 12. Solution. 24 divided by 12. Now if you watch, you will notice that these 2 numbers, 24 and 12, are both divisible by 2 because both are even numbers. So we now fall back to our tests of divisibility by 2, 3, and other numbers. Alright? What we are looking for is a number that can divide both the divisor and the divider. Let's call that number a factor of the divisor and the divider. Alright? So, since 24 is even and 12 is even, then 2 can divide both. Therefore, we go 2 divide 12, 6. 2 divide 2, 1. 2 divide 4, 2. 2 divide 24 is now 12, right? Good. Now you notice that here we now have what? 12 over 6. We have reduced it from 24 over 12 to 12 over 6. Now we go again. Are both even? Yes, they are both even. So 2 can still divide, right? Good. Now 2 divide 6, 3. 2 divide 12, 6. 6 over 3. Can 2 divide again? No, because this is even, but this is odd. So since 2 cannot divide 3 without a remainder, we will not use 2. Remember, whatever number you are using to divide the denominator, also use it to divide the numerator once. So let's go. 3 divide 3, 1. 3 divide 6, 2. 2. What that means is that 24 divided by 12 is 2. Alright? So short division is simply a systematic way of reducing number till we get to a point whereby nothing else can divide. Alright? Let's solve one more example. One or two more examples. Let me call this example number 5. Here I have, make it a bit big, 5,264 divided by 16. Solution. 5,264 divided by 16. Even. So what do? We use 2. We keep on reducing this number till we get to a point whereby nothing else can divide. Or till we get to a point where 1 becomes the divider. Alright? So let's go. 2 divides 16, 8. Remember, short division means dividing digit by digit. 2 divide 5, 2 remainder 1. 2 divide 5 is 2 remainder 1. Is it not? Good. Now, remember that this is your quotient. This is our remainder. So we write down the quotient and we carry our remainder to the next number and put it here. What number are you seeing now? 12. Now you go again. 2 divide 12, 6. 2 divide 6, 3. 2 divide 4, 2. Okay? Are you following? Alright. Now, we now have this to be 2,632 divided by 8. We divide by 2 again. 2 into 8, 4. 2 into 2, 1. 2 into 6, 3. 2 into 3, 1 remainder 1. You put your remainder here. 12, right? 2 into 12, 6. So we now have 1,316 divided by 4. We use 2 again. Alright? 2 into 4, 2. 2 into 1, can it go? No, because 1 is less than 2 that is dividing. So we join 1 and 3 together to have 13. 2 into 13 now is 6 remainder 1. Put that one here. You see, you are now seeing a number that looks like 11, right? Becomes 11. 2 into 11, 5 remainder 1. Put that one here. It becomes 16. 2 into 16, 8. So we now have 658 divided by 2. Can 2 still divide? Yes, it can. Because here is an even number. Okay? So 2 divide 2, 1. 2 divide 6, 3. 2 divide 5, 2 remainder 1. 2 divide 18, 9. So we now have 329 divided by 1. That's what I'm saying. We keep on reducing it till we get to divide the 1. Now, any number divided by 1 is what? That number. Don't forget. Okay? That's one of the rules of division. Any number divided by 1 is that number. Any number divides 0 is 0. But 0 cannot divide any number. It becomes undefined, indeterminate. Alright, let's solve this final example on short division. Number 6. Example 6, here I have 2,160 divided by 80. number ending in 0. Solution. 2,160 divided by 8. Now, whenever you have a number ending in 0, dividing another number ending in 0, it becomes simple. The first thing we need to do is to take away the zeros. Okay? So we can simply say that this 0 will cancel this 0. Now we are left with 216 divided by 8. Here we can reduce, or we can use the test of divisibility by 8. Remember that divisibility by 8 says that if the last 3 digits is divisible by 8, then the number can be divisible by 8. But we have only 3 digits here. So let's use 2. Since this is even, 2 comes here, 4. 2 into 2, 1. Since there is no number here, and here is 16, if I say 2 into 16, 8, and I write 8 here, I will be wrong. So, since short division is digit by digit, 2 into 1, can it go? No, right? So we have 0 here. Then we now merge 1 and 6 to be 16. 2 into 16, 8. Or better still, if this will confuse us, we merge 2 and 1 together to be 21. 2 divided 21 is 10 remainder 1. Put that one in 16. 2 divided 16 is 8. Okay? So here I have 108 divided by 4. 4 here, let me use 2 please. 2 here, 2. 2 into 10, 5. 2 into 8, 4. 54 divided by 2. 2 here, 1. 2 into 5, 2 remainder 1. 2 into 14, 7. 27 over 1. Any number divided by 1 is what? That number. Alright? So, this is the concept of short division method. Alright? This is the concept of short division method. It's simply a method where we divide numbers digit by digit. Alright? It's simply a method where we divide numbers digit by digit till we finish. Okay? Now, having said that, let's quickly look at long division. Alright? Long division. Long division is used in 2 forms. You can use it to divide numbers. You can also use it to express numbers as decimal numbers. Okay? But for now, we are using long division to divide whole numbers, or let's say perfect numbers. Numbers that when we divide, our answer becomes a whole number. That's what we learn now. By the time we start touching fractions, we will start learning long division, the use of long division in expressing fractions as decimal numbers. Alright? Okay. Long division method. Long division method. Examples. Divide the following. By the following. Here we have 32 divided by 4. Solution. Remember that in short division, we write this as 32 divided by 4. Now, in long division, the long division sign symbol is always like this. Okay? Okay? Then our divisor will be inside the symbol, while the divider will be outside. Alright? It's always like this for long division. Then let's divide. 4 divided 32. Ask yourself, what times a number that will give us 32? 4 times what will give us 32? 4 times 8, right? So 4 divided 32 is 8. We write it here. This up here is where we have our quotients. 8. Now, whenever you divide and have a number here, the next thing to do is to use that number, which is your quotient now, to multiply the divider. Remember that 4 is divider. Okay? Use it and multiply the divider and subtract it from the divisor. Now, 8 times 4, 32. We subtract from here. 32 minus 32, 0. Now, here is always our remainder. Okay? So you can see that 32 divided by 4 is 8 remainder, 0. Alright? Let's look at this example number 2. I have 288 divided by 9. Solution. 288 divided by 9. So, the long division sign. Remember, 9 outside, 288 inside. Now, looking at this, you see that this is a very big number. So, we solve this as if we are solving short division, even though we are not doing short division. Now, what we do here is, we say 9 divide 2. Can 9 divide 2? No. Because 2 is less than 9. So we now take 2 and 8. These two together. Are you seeing it? And divide by 9. So we are now looking at 28. 28 divided by 9 is what? 3 remainder 1. Because 9 times 3 is 27. And 27 plus 1 is 28. Right? So 9 divided 28 is 3 remainder 1. 3 remainder 1. Okay? Now what do? We remember that 3 is always our quotient. So we write out our quotient 3 and do away with the remainder. We don't need it. So we can always say we throw the remainder into the trash can. Okay? Then what's the next thing to do? We use our quotient to multiply the divisor, the divider rather, and take away from the number we divided. So let's go. So we have 3 times 9, 27. Am I going to write my 27 here? No. I will write the 27 directly under the number I divided, which is what? 28. And we do what? We take away. We minus. What do we do? What happens to this 8? We bring it down. 8 is here. 28 minus 27, 1. I see it. Okay. Now, we now have a new number here, 18. Can you see it? Now, we now ask ourselves, 9 divide 18. We divide again. 9 divide 18 is what? 2. Because 9 times 2 is what? 18. So, 9 divide 18 is 2. We write the 2 here at the back of the first quotient. 2 times 9, 18. We write it under what we divided and minus. 18 minus 18, 0. So we can now tell ourselves that therefore 288 divided by 9 is equal to what? 32. Are you seeing it? So the idea here is that we divide, multiply, subtract till we get the remainder 0. Okay? Till we get the remainder 0. Let's solve another example. Let's solve another example. Number 3. Remember, the idea is to get to remainder 0 or a remainder that is less than the divisor. Number 3. Okay, let's look at this. 179 divided by 5. 179 divided by 5. Let's go. Solution. Long division. 5 outside, 179 inside. Now remember, 5 divided 179 is a big number, okay? So you do what? You take them digit by digit. 5 divided 1, can it go? No. So we take 1 and 7. 5 divided 17. Let's go. 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. Now, I'm writing this down because I'm also making use of the multiplication table. Now, 5 divided 17. We are looking at 17 only. 5 divided 17, you notice that 5 times 3 is 15. And 15 plus 2 will give me 17. What it now means is that 5 divided 17 is 3 remainder 2. So we have 3. And do what to the remainder 2? Put it in the trash can. We throw it in the trash can. Okay? Then what next do we do? I'm going to leave this here actually. But what next do we do? We multiply 5 by 3 and subtract it from 17. 3 times 5, 15. Put it down here. And minus. What do we do to this 9? We bring it down. 17 minus 15 is what? 2. Now we have 29. Let me take away this bracket now. 5 divided 29 is what? Let's extend. 5 times 5, 25. 5 times 6, 30. See, we are more than 29 already. Now, you notice that 5 times 5 is 25, and 25 plus 4 is 29. Meaning that 5 divided 29 is 5 remainder 4. So we write our 5. What do we do to the remainder? Put it in the trash can. 5 times 5, 25. We subtract here. We subtract 25 from 29. 9 minus 5, 4. 2 minus 2 is 0. So 29 minus 5, 25 is 4. Now, can 5 divide 4? No. We leave it like that. You can now say that, therefore, 179 divided by 5 equal to 35 remainder 4. Quotient remainder 4. Okay? Alright. Alright. Let's have one more example and we are done. Okay? Example number 4. So I have 128 divided by 3. Solution. Long division. Sign 3 outside, 128 inside. Now let's go. 3 divide 1, can it go? No. We take 1 and 2 together. 3 divide 12. You can still use 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 9. 3 times 4, 12. 3 times 5, 15. Now you don't notice that. 3 divided 12 is what? 4. Because 3 times 4 is 12. So here I have 4. Any remainder? No remainder. 4 times 3 is what? 12. Remember, we write it under the number we divided. We bring down 8. 12 minus 12, 0. Right? There we go. 3 divide 8. Notice that 3 times 2 is 6, 3 times 3 is 9. 9 is more than 8. So 3 times 2 is 6. Meaning that 3 divide 8 is 3 times 2 plus 2. 3 times 2 is 6, 6 plus 2 is 8. Therefore, 3 divide 8 is 2. Remainder 2. Throw the remainder into the trash can. 2 times 3, 6. 8 minus 6, 2. 3 divide 2, can it go? No. Therefore, I cannot say therefore, 128 divided by 3 equals 42 remainder 2. Alright? Okay, so this is the concept of long division method and short division method. Okay? Alright, this brings us to the end of this class. Remember, watch the video over and over again and ask me your questions. Then in our live class, we will treat about division of numbers, long and short division in more detail. Okay? Alright? Okay, so we'll stop here for now and I'll see you in our next class. Bye.